Hello everybody. In this video, let's continue the CODESYS course with the ladder logic instructions. In this video, I will explain the three categories of instructions in ladder programming. Like the previous videos, I create a standard project. On the right side, the ladder instructions can be viewed. Now let's start the last category, ladder elements. The first item is the network. Each part of a program has to be written on a network. These instructions related to the contacts, the coils, the timers, and the counters were explained in the previous videos. Now, let's see how a move instruction works. Its first input is used to enable it. This instruction copies a specified value at its second input to the destination variable on the right side. Note that if you define a new variable as a destination variable, based on the input data type, a suitable data type will be selected for the output automatically. Now the input is a real number with a fractional part. As you can see, the selected data type is LReal. It's an abbreviation of large real numbers. Because the entered number is small, I can use real format too. Now let's use another data format. For example, let's select the integer format by selecting the int item. This data type is used to store integer numbers. Therefore, it cannot store real numbers with their fractional part. As you can see, this red line means that there is a problem. Now let's download the program. Now this message says there are compiled errors. Do you want to log in without download? Let's return and resolve the problem. I have to change the data type of the b variable to real or use an integer number as the input of the move instruction. Now the input number and the data type of the b variable are the same. So there is not any error and I can download it to test the move instruction. Now if I enable this contact, the number 56 will be moved to the variable b. Let's log out and see how does the next instruction work. Its name is jump. As the name implies, it makes a jump in the program execution. To see its effect, let's extend the program a little. A jump instruction directs the execution of the program to another network. Now let's add a label to the last network and then select it as the jump destination. Now let's test the program to see the performance of the jump instruction. Now the jump instruction is not activated. So these two networks are executing, and if I change the state of these contacts, their connected coil will be enabled too. Now let's enable the jump instruction, which directs the execution of the program to the third network. Therefore, the second network is not executing, and this contact is not able to turn this coil on. Alright, let's learn usage of another instruction. Its name is return. Let's change my program a little and then use the return instruction. Now, let's test the program. As you can see, only the first coil has been enabled because when the return instruction is enabled inside the program organization, like the current one, or inside a function or function block, the remaining program after the return instruction won't be executed. Alright, the last two tools inside the ladder elements category add branches to programs. Now let me change the program a little and use them. As you can see, when a branch is selected, valid locations will be indicated automatically. Let me add it between these two contacts. Now I can write a program and finally end it with a coil instruction. Okay, let's use the undo icon and then use the last ladder element, branch start end. Similarly, when it is selected, valid locations are specified automatically. After selecting a location as the start point of the branch, valid locations as the end point of the branch will be indicated. Well, let me add another branch. Alright, let's continue to learn the function blocks category. The first two functions are used to detect rising and falling edges. Remember, during the previous video, positive and negative contacts were used to detect rising and falling edges on the receiving signals from the sensors. Again, let's change the program a little to use negative contacts and its similar instruction, falling trigger. Well, this is a positive contact to detect rising edges. Let's replace it with a negative contact. This program can detect falling edges on the state of the C variable. In other words, if it is enabled and the state of the C variable changes from 1 to 0, this contact produces a pulse. Now let's write its equivalent program with the falling trigger instruction. Similarly, the falling trigger instruction detects any negative changes on its input. For now, it only depends on the C variable. So the performances of these two programs are the same. Note that the produced pulse turns these variables on only during one scan cycle of the program execution. For this simple program, it's about 1 or 2 milliseconds, which is a very short time. So instead of simple coils, usually set and reset coils are used after the instructions which detect rising or falling edges. As I mentioned earlier, the performance of these two lines is the same, but there is a little difference between them. Note that this contact must be activated to detect falling edges on the C variable, but the falling trigger instruction works based on its input state, not based on its previous contact. Let's add another contact and then test the program. As you can see, I cannot use only the C variable to turn the output coils on. Based on the program, I must enable the first contact A. After that, if the state of the C variable changes from 1 to 0, the program activates these variables. Alright, the next two instructions are the SR and the RS. Although I used the RS instructions in the previous video, now let's use both to compare their functionality. As you can see, the data type of these selected variables for the first one is the RS, but for the other one is the SR. Note that these two instructions have two inputs to set and reset their connected coils. So it is unusual to use the set or reset coils at their outputs. Let's change them to simple coils. Again, let's test the program. Well, both RS and SR instructions have two inputs to set and reset their outputs, but if both inputs are activated, the RS instruction will reset the output, but the SR instruction will enable its output. This is the difference between these two instructions. Naturally, if only the reset input is used, both will disable their outputs. Alright, the next category is other operators. Now let's continue this video with the math operators. Well, I have changed my program a little and now I want to use an add instruction. As its name implies, it can be used to add some similar numbers together and store the result on a variable. Note that if a new variable is used to store the result, CODESYS will select an appropriate data type for that automatically. Now the selected data type is UINT, which is an abbreviation of unsigned integer numbers, because the inserted add instruction needs to store the result of adding two positive integer numbers. Note that I can use the input item to increase the number of inputs of some math operators. Also, I can use stored values on other variables instead of using constant numbers. Similarly, the next three instructions can be used for subtracting, multiplying, and dividing. Now let's use the sub instruction. As you can see, the selected data is real. Because this data type is used to store real numbers, it can also store integer numbers. Another data type that I can use is LReal. It's a suitable data type when we are dealing with a large scale of real numbers. Now let's use the real data type and test the current program. As you can see, when I enable the math operators, they store the result on their outputs. Note that, like Boolean variables, I can change the stored numbers manually and then press the Ctrl plus F7 keys on the keyboard. Alright, the next type of math operators are used to compare two values. Let's use one of them. Well, this math operator is called less than. It takes two numbers with the same data type. If it is enabled and the specified value at the first input is less than the second input, its output will be enabled and it can be used to turn a digital output on. Alright, let me enable the comparator instruction. Now the first number which is determined during the program is equal to 70 and it's not less than 20. Therefore the output will remain off. Now let me change the second number. Currently the first number is less than 100. So the comparator instruction has enabled its connected coil. Okay, I explained the three categories of ladder logic instructions. Now I will explain the other remaining instructions and I will test them. First, let's create a standard project like the previous videos. Let's start learning the instructions related to the Boolean operators. Remember, I explained the AND, OR, and XOR logics using simple contacts. Let's see how the last one can be used. As you can see, the inserted XOR instruction has an input to enable it. It performs the XOR logic between the next two inputs. On the other hand, a variable can be specified to store the result. Before testing the inserted XOR logic, let's write its equivalent program using some simple contacts, which I explained in lesson number 2. Alright, these two programs do XOR logic between the same inputs, A and B, and store the result on the two distinct variables. Now let's test them. Okay, let's enable the XOR logic. Remember, I press the Ctrl plus F7 keys on the keyboard every time I want to change the state of each variable manually. Now, based on the program, when I change either the A or the B variable, these two variables will be changed similarly. Alright, other logic can be tested similarly. Now let's go to the other operators category. Its first instruction is called binary selector. Let's test it. As you can see, the instruction has 4 inputs. The first one is used to enable it, like many of the other instructions which were explained until Now, the data type of the second input is binary. If it is 0 or false, the next value will be sent to the destination variable. Its data type can be anything such as Boolean, real, or integer. The important point is that the data type of these inputs and the destination variable must be the same. Finally, if the second input is equal to 1, the last input will be sent to the other side. Now let's test the program. Well, let's enable the instruction. Now its second input is false. Therefore, the stored value on this variable has been selected. Let's change its value. Okay, I forgot to launch the simulation mode. Now let's change the state of the second input to true or 1. At this time, the specified value at the last input has been sent to the other side. Let's continue with the next instruction, which is called the multiplexer. Similarly, it can be used to select a value or a variable. Note that the data type of the second input is an integer. Like the previous instructions, if its value is equal to 0, the third input will be selected, and if its value is equal to 1, the fourth input will be sent to the other side. Furthermore, the number of inputs can be extended. Okay, the number of inputs is increased. Note that the data type of the inputs and the outputs variable must be the same. Let's work with the real numbers. Automatically, CODESYS will select this data type for the output variable. Now, if the second input is changed to 2 or 3, the last two inputs are selected respectively. Now let's test the inserted multiplexer. Okay, let's enable the instruction. Now the current value of the second input is 0, so this number has been selected. If I change it to 1, the next input will be selected. Let's change its value. Similarly, the second input can be used to select other inputs. Note that if the selected number at the second input is too large, the last input will be selected. Well, the third instruction in the other operators category is limit instruction. It's very commonly used in ladder logic programming. It gives us a simple way to make sure that the specified value remains between two distinct values. First, we should select two values as the desired mean and max limits. Then specify the variable whose value must be restricted. Now, if the value of this variable is a number between 10 and 100, it will be sent to the other side without any change. If its value is lower or higher than 10 or 100, these two numbers will be sent to the other side respectively. Now let's test the limit instruction. Now the current value of the input variable is 0, which is lower than 10. So the number 10 has been sent to another side. Let's increase the input number. Now its value is 10, which is a number between 10 and 100. So the instruction has been sent to another site without any change. Finally, if the input number is greater than 100, the maximum limit will be used on the other side. Let's continue. The next instruction is move, which I explained in the previous video. The next one is conversion. It can change the data type of stored numbers. Note that there are several data types in PLCs. For now, I am going to use this instruction to convert a number that is a real number to an integer one. Naturally, its fractional part will be omitted. Note that instead of writing the conversion type, I can click here and find my desired conversion. As an example, let's select this one, which converts its input number to an integer number like the previous one. Now let's use suitable variables for the inputs and outputs. Note that the selected data type for the conversion output is not Boolean, it's an integer. Therefore, instead of using coils, the assignment item must be used. Now let's change the input number and see the converted number on the other side. Note that the performances of these two networks are the same. Well, let's continue to learn other instructions by clearing the current program. The only remaining category on the right side is the general one. Note that the first item can be used to add a network to the program. The next two instructions are called bugs with a little difference. Both can be used to enter an instruction from the CODESYS library, but the second one has an extra input to enable. I can write any instruction name or click here to open this window and then find my desired instructions. For example, the counter instructions or a math operator like addition, which I explained already. As you see, more instructions are accessible inside the window compared to the right side. For instance, this one returns the exponential value of its input based on Euler's number. This one is abbreviation of the shift right instruction. Although there are lots of instructions and it is not possible to explain all of them during this CODESYS course, you can test and learn them as well as the instructions the way I tested them until now. For example, let's test this one. It calculates the absolute value of its input. Note that you can use the help window and search for any instruction name to learn what it does. Alright, as you can see, the instruction calculated the absolute value of its input minus 25, which is equal to 25. I explained the other instruction in the general category during the previous videos, except this one that it can execute a simple program in a structured text language. Now let me write a simple program in a structured text. I will do a more practical project with this language later. For now, assume if the stored value on this variable is less than 10, this Boolean output must be on. Otherwise, the program must turn it off. Now let's compile the program to ensure there isn't any error, and then download and test the program. Okay, let's enable the inserted instructions. As you can see, the condition is satisfied, so this output is on. Let me change the stored value on this memory. Now this part of the program has turned this output off. Again, let's decrease this value to less than 10 to turn this output on. Alright, I explained all the instructions on the right side. You can use the help window to learn other instructions. In the next video, I will explain how other program organization units, functions, and function blocks can be used to write more efficient programs. Thanks for watching this video. See you at the next one.